This example of model execution is supported by a model of a dishwasher. The dishwasher has the following requirements. Its primary purpose is to wash, rinse and dry the dishes. For maintenance reasons, the dishwasher must enter a maintenance state after 4 cycles and should not be usable until servicing is performed. It has 2 modes, quick and intense, which is to be chosen by the user. If the door is open during the cycle, upon closing of the door the dishwasher shall continue the cycle from where it stopped. The systems engineer described in the model the behavior of the dishwasher using a state machine. The state machine has 3 macro states: running, service, and mode. The running state describes how the system goes from off to on and open state when the door is opened. In on state, the system transitions from washing, rinsing and drying until it is finished. The service state describes how the system switches from normal state to faulty state in which servicing is required. The mode state shows which mode is selected by the user. We will now begin the execution. The purpose of the following execution is to check that the behavior modeled is correct versus the requirements. In traditional document-based systems engineering, this kind of behavioral description is done using a collection of drawings and textual description. The collection of documents is passed to the engineering specialties such as subsystems, software and simulation team, etc. Due to the nature of documents, it is very difficult for the systems engineer to verify that the behavior described in documents is without errors. If an error is present, it can go unnoticed during a long period and its correction will be costly and time-consuming. The later it is discovered, the more difficult it is to correct it. The state machine diagram is animated and show in purple the initial states of our dishwasher. On the top right is a small user interface to interact with our system. The user interface is tied to the state machine states, transitions and events. Note that this user interface can be more advanced and can be very useful for early validation with end users of the product. On the interface is available a start button to launch the washing cycle and 2 LED indicating if the dishwasher is off or on. The user can switch between 2 modes using the mode button. Each mode has a dedicated LED. The door can be opened and closed using dedicated buttons and the LED indicates its status. A digital screen indicates which operation the dishwasher is performing with the remaining time. On the top right is indicated the number of cycles and a fault LED which indicates that maintenance is required. Finally, the service button simulates the maintenance being performed. We start the washing cycle in intense mode. As you can see, the state machine diagram is animating and we can see in which state our system is in. The sequence diagram on the bottom right is built on the fly as the execution goes.